Inside control, the room stays almost silent, except for cooling fans and timing pulses crossing the acoustic monitors. Then, one of the returns answers early. A technician lowers transmission power, runs the sweep again. Same heading, same velocity. The signal comes back cleaner this time. Too clean. A second echo forms underneath the first, while methane rain rattles faintly across the exterior microphones above Kraken Mare. Nobody speaks for several seconds. One canyon wall on the terrain render drifts sideways between refresh cycles, like the ocean floor is sliding underneath the submarine in real time. The vehicle stabilizes. The seabed does not. The return arrives too early. Titan Submarine Mapping Control watches the pulse arrive almost 3 seconds ahead of projected timing, while the vehicle is still completing its previous sweep across Kraken Mare. The first assumption is a calibration fault. One operator lowers transmission power and reruns the scan without changing the vehicle heading. The same section of sea answers twice. A narrow return appears first. Then a second echo arrives behind it from a slightly different angle, even though the transmission path never changed. The terrain map starts placing both returns on top of each other. Seafloor ridges overlap open water. Distance markers shift by a few feet every time the system refreshes. Nobody stops operations yet. Titan's methane seas distort sonar differently than Earth oceans. Temperature layers near the surface can stretch acoustic timing enough to distort a clean return. The software normally smooths that instability out after a few passes. Instead, the opposite starts happening. Each lower power sweep pulls the two echoes farther apart. The false return grows cleaner, more precise. One technician checks the timing traces against the vehicle clock, while another rebuilds the navigation alignment from scratch. The clocks match. The pulses do not. For several minutes, the control room keeps mapping terrain from conflicting returns. The map continues updating anyway. Stable sections of seabed remain fixed, while one canyon wall slowly shifts sideways between refresh cycles, like the sea itself is moving underneath the scan. Recovery now depends on deciding which echo is real before the vehicle reaches the next descent corridor. The system keeps drawing both. The old signal comes back inside a future scan. For almost 20 minutes, the terrain appears stable. The drifting canyon wall holds position. Depth contours stop separating. Operators begin rebuilding the suspended mapping route, while the submarine continues forward through the northern basin of Kraken Mare. Nobody fully trusts the recovery, but the screens behave normally long enough for routine work to resume. Then, an older ridge formation appears inside a fresh transmission. At first, it looks minor, a faint overlap near the lower edge of the render. One technician assumes the display cached part of the earlier sweep and clears the layer manually. The shape disappears. The next scan brings it back. Now the old terrain arrives, rotated slightly sideways, inside a completely different section of seabed. Rock formations mapped almost an hour earlier begin appearing beneath current water depth returns. One operator leans over a second console comparing timestamps by hand, while another pauses automatic filtering across the acoustic pipeline. The submarine stays on course. The terrain keeps changing around it. Titan's hydrocarbon seas can hold acoustic reflections far longer than Earth oceans. Delayed returns are expected sometimes, but if the filtering correction worked, the scans should become cleaner with time. Instead, older returns keep appearing inside newer scans. The recovery software is now blending delayed echoes into active terrain reconstruction. Every correction pass feeds older echoes back into the system again. Historical separation stops meaning anything reliable. Past and present scans begin occupying the same operational space. Nobody shuts the mapping run down yet. The submarine keeps moving through black liquid beneath Titan's haze, while the terrain display slowly fills with seabed features from somewhere else. The same ocean now exists in two different shapes. Inside Titan's submarine control, two independent terrain models are now running side by side across separate processing systems. One shows a narrow descent channel opening safely beneath the vehicle. The other shows solid ridge structures occupying the same water less than 200 feet ahead. Both models come from the same incoming scan. Nobody agrees which version is real. A second verification team isolates the raw signal feed from the filtering software entirely. For several minutes, the room settles back into manual verification. People compare timing paths manually. Navigation overlays update in silence. Someone starts marking possible maneuver corridors onto printed depth grids because the live models will not hold still long enough to annotate. Then the separation grows worse. The left navigation system pushes the submarine east to avoid terrain the right system does not detect at all. Autonomous guidance rejects one route, accepts another, reverses the decision seconds later after a delayed acoustic layer finishes processing through the queue. The same data should produce the same map. Instead, every new transmission pushes the systems farther apart. Communication delay with Earth leaves almost all navigation authority local. The vehicle cannot wait for outside confirmation before maneuvering through submerged canyons this tight. Operators have to keep moving while the terrain underneath the vehicle changes shape between systems. The same stretch of ocean now carries two different layouts. One technician finally disables automatic route correction entirely. The submarine continues forward under manual oversight, while two separate terrain maps slide across neighboring screens, showing different walls in different places around the same vehicle position. Neither display fully stops moving. The submarine still moves. Nobody fully knows what it is navigating through anymore. 3 days after the first unstable return, the mission authorizes continued descent operations beneath Kraken Mare. Transmission cycles remain clean. Navigation holds steady. Most movement commands now execute without visible correction drift. From the outside, the recovery appears successful. Inside, control the uncertainty never actually disappears. Communication delay between Titan and Earth prevents immediate external review of the adaptive processing system, now controlling most environmental reconstruction. By the time deeper analysis arrives from Earth, the submarine has already moved miles beyond the acoustic conditions being reviewed. Local operators stop waiting for perfect confirmation because the mission cannot pause long enough for it anymore. So the navigation system becomes the final decision layer instead. The submarine still moves. Nobody fully knows which version of the terrain it is following anymore. A few engineers continue checking raw signal traces at the beginning of every shift. Most of the time, the acoustic returns look stable now. Sometimes an older echo still appears inside newer scans, for less than a second before the correction system folds it back into the terrain model again. The route display never reacts visibly. The vehicle keeps moving forward. After a while, nobody reacts to it anymore. The mission survives. But survival now depends on navigation systems human teams can no longer fully audit while operations are happening. Future Titan exploration procedures quietly update around the assumption that real-time environmental verification may never remain completely reliable inside hydrocarbon oceans this deep. Nobody announces that change directly. The submarine continues transmitting from beneath the black liquid, while stable terrain maps keep rebuilding themselves from signals the operators no longer fully separate into past and present.